So I have declared this table and really wanted to discuss some of the core functionality about the linked list. And as we know that most choices in the computer programming and design, right, so null method is well suited for all circumstances, right? And if you see, the linked list data structures might work in the some of the cases, but causes problem in some other scenario. So here I am not comparing the linked list data structures with all the data structure what we have. I'm just trying to compare with the array data structure. So what does it mean about the indexing, right? So when it's comes about the indexing, so what I'm trying to say that I have been given 11, 12, 13, 14, and this array I have been given, okay, and we have 0, 1, 2, 3. So if you want to access the second index value, simply you can do array of 2, or if you want array of 3, you can do like this. And both is nothing but it's a constant operation when you try to do these operations. If you're trying to access any of the index values, simply you can do array of index and then you can give the index value and you will get those the data. But when it's come about the linked list, suppose the linked list has been defined in such that 11, 12, 13, 14 and null, okay, and if somebody is asking you the position equal to 2, so if this is the positions 1, 2, 3, 4, and if you wanted to access the second positions, what you need to do, you need to traverse from head, okay, so this is head has been given, you need to traverse from head and you need to go to the positions 2, so you can get the position index and then you will able to return the value. So in the worst scenario, so if you are considering the position 2, right, you need to go from 1 to 2, but if somebody is asking you to go give me the value from the end of the linked list, you need to traverse the entire uh, linked list and then you will able to give the value from the tail node. So that is the reason the time complexity of the linked list when you are doing the indexing is going to be big O of n. When it comes about the array, you will able to access any of the index values in the constant operation, right? Now second thing, it's pretty much and so better than the array in this particular scenario, in this three scenario, right? So when somebody asks you to insert and delete at the beginning, right, suppose if somebody is asking you insert 10 here, okay, in the array, which is not possible because index out of range, because -1 index is not available. But if somebody is asking you to insert 10, so you can create one node, okay, and this node you can ask to point to head of the linked list and this is done. So that is the reason it's told that insertion is the constant operations if you try to add the value at the beginning. Second, it's similarly insert and delete at the end. So if somebody is asking you to insert 15 here in the array, right, and you will not be able to add because fourth index is not available and it will give the index out of range error if you try to add 15, right? But when it comes about insertion at the end of the linked list, I will take same example once again. 11, 12, 13, 14, okay, and if I wanted to insert 15, what I can do, I can create one 15 node, okay, and I can ask this tail node to point to the new node and this is done. So insertion is constant operations, but the consideration is if you know the tail node. If you doesn't know the tail node, then might be you need to get the tail node, right? You need to traverse from head uh, to all the node, and then you can reach where node dot next is not equal to null. Then you can get the tail node, and simply you can do tail node dot next equal to new node. This is how the addition of any node inside the linked list at the tail. Right, and this particular operation which is not possible in array. So insert and delete at the middle. Okay, if somebody is asking you like insert 15 in between, right, somewhere inside the array, this is not possible because we have the limited size of the array and we cannot push anything in between. Okay, but when it comes about the linked list, as it's not continue in the it's not contiguous in memory. So suppose we have given 11, 12, 13, 14, and I have the null. Okay, and I wanted to add one new node. Suppose I created one node 16 and I wanted to add in the position 2. So what I can do, I can ask the second node point to the new node, and new node will point to the next node, and this is all about. And we can do insert operation. The one additional operations what you need to do, so use the positions index. So if you know the position index, easily you can do, but if you do not know, again you need to find the position node as we have done for the tail node. So you need to go from the head and need to traverse next, and then you can find the position node, and position node dot next equal to, you can assign the value to the new node, and again new node, right, equal to next node, and this next node you can store somewhere in the temp variable. So, and third, we will discuss each and every operation in the detail. So when we'll take the demo, live demo, so I will show how we can create the linked list and how we can do insert, update, delete operations. At the time we will see how we are going to do all these operations. Here I'm just trying to give more information about the concept. And third thing what we have here, like the waste of the memory. Okay, so as we have seen in this case, that whenever you're trying to declare one linked list, right, so we do the data and we do the next pointer. So this is the waste of the memory. So if you are trying to allocate 6 node, right, so your size is going to be 6 into 2 equal to 12. So unnecessary, just we are increasing O of n space. But in array, if your size is 5, that means you are utilizing all the 5 spaces to store the values. So this is all about the trade-off of the linked list data structure, because we are studying linked list, so we should know what are the pros and cons when we are choosing the linked list data structures compared to the array. And we have seen like indexing and the wash and the waste space. In this two scenario, linked list is not good, but when it comes for the insert, delete at the beginning and insert, delete at the end and insert, delete at the middle, which is really not possible in the array. If you clearly see these all three operations, we cannot do the inside the array. And this is the limitation of the array we have. And whenever you do this kind of operations, right, definitely we need to think about the linked list data structures. Okay, so a note of this, I'm closing this video, and we will try to deep dive little more in the next video. We'll try to get some more information about what are the disadvantages we have while implementing the linked list. And before that, in the next video we will try to understand the basic concept and the nomenclature which has been used in the linked list, and we will see how the singly linked list, doubly linked list, and circular linked list work. Okay, and post that we will see some of the live demo, and we will create our own data structure, and we will try to do all the most of the method like add, insert, update, delete, and we will see how those methods work. So if you have any doubt or anything, you can provide those provide in the comment, so and I will try to clarify in the